Hello guys, in this video I am going to explain more about the cost diagram. So when it comes to trigonometry, it's best that you know the cost diagram like the back of your hand. It is very important with most of the trigonometric questions you are going to be getting, especially in grade 12, even in grade 10 and 11, but there's more emphasis to it on grade 12. So you want to make sure that you know how to go about using the cost diagram to your advantage on specific questions, right? So without any further ado, let us go ahead. So with the cost diagram, you just kind of want to know that we will be working in a Cartesian plane, but this time around we're going to be working with angles. So we know that with a 0-degree angle, it starts here. And in which direction does the angle increase? Clockwise, right? So going in this direction from 0, here we're going to get 90 degree, clockwise again, 180 degree, clockwise, 270, clockwise, and then we're back to our starting position. So basically 0 degrees and 360 degree share the position, where 0 degrees is the starting, 360 is the ending at the same point, right? Now, next thing we want to look at is what is cost? Do you remember what is cost? Let us go ahead and place these 4 letters on each quadrant. So we know that C is here, A is here, S is here, T is here. Cost, right? And we know that C is for cos, A is for or, S is for sine, T is for tan. So you just want to immediately know that cos is here, all is here, sine is here, tan is here. And then the next thing we want to look at is the angles. So yeah, we know that at the sine quadrant, it's 180 degrees minus a particular angle. At tan is 180 degrees plus a particular angle. Cos is 360 degrees minus a particular angle. And then at all, you can just say it's 360 degrees plus a particular angle. With this angle, this particular angle over here, the angle must be less than 90 degrees. Which would make sense, right? Because 180 degrees minus any angle that is less than 90 degrees is going to remain in this quadrant. So 180 minus a specific angle, that is less than 90 degrees, it's going to be on the sine quadrant. Hence, we would put this general equation over here. Same thing here. 180 degree plus any angle less than 90 degree. It won't exceed 270. So it will remain in this quadrant. Same thing here. 360 minus a particular angle. It will remain between 270 and 360, etc. Right? So that is one thing you have to, or at least in your case, you want to remember. And so how do we use these? So these angles are used for reduction when you're given a certain trigonometric ratio and then the question maybe asks you to reduce it. So just remember, a trigonometric ratio is sin, tan, cos. That's what you essentially call a trigonometric ratio. It's sin, tan, cos, and the others like cot, but in this case we're just focusing on sin, tan, cos, right? So for example, if a question says sine 151 and then the question asks you to reduce or simplify this given trigonometric ratio, first thing you want to look at is the angle. This 151 degree angle, in which quadrant out of these 4 is 151 located at? We can see it's located between 90 and 180 degrees. So in this sine quadrant, right? And so after identifying that, okay, 150 is at the sine quadrant. Now, since it's at the sine quadrant, we're going to be using this form of this sine quadrant, right? We're going to say sine 180 degree minus, what is this angle? To get this angle, you can just say 180 minus the given angle. So in this case, it's going to be 29 degrees. After writing it in this form, you want to do what we call reduction. We are reducing this. So by reducing is, we want to make sure that we just end up with this angle. We don't want the 180 minus. So once you got it in this form, you're just going to write the trigonometric ratio again, which is sine, and then you're just going to write 29 degrees. You're excluding the 180 minus. So you essentially reduced it from sine 151 to sine 29 degrees. And since at the beginning of the question we were working with sine, right, and we saw that this degree is in the sine quadrant, so if the question is given as sine and this degree is at the sine quadrant, it means that after reduction this is going to be positive. But if it was given as cos 151 preapps, this angle would still be at the sine quadrant, right? But it would be in a form of cos. So what I'm saying is, if the question was given as cos 151 degrees and then they ask us to reduce or simplify, we would go on to say, same form, we write it as 181 minus 29 because this 151 is in the sine quadrant, so we use this form. But after reduction, yes, we're going to keep cos and then we're going to keep this angle over here, but now it's going to be negative. This negative just means that the cos does not belong at the sine quadrant. So if you're given a question in cos 151, the angle and the given angle is in the sine quadrant, it means that you're going to end up with a negative as your final answer with the same reduction procedure, just with a negative. Yeah. Essentially think of that negative as if, hey, I'm cos, I don't belong here because sine belongs here. If it was sine would belong here and it would be positive. Positive, you belong there. Negative, I don't belong at that quadrant, so we're giving you a negative. That's how you can see it. So, with another example, we can just further emphasize on that point. We can say that maybe if you're given cos 190 degrees, where's 190 degree? It's at the 10 quadrant because it's between 180 and 270, right? 190 degrees between 180 and 270, and thus in the 10 quadrant. And thus, we're going to write this angle over here in this form. So it's going to be cos 180 degree plus 10 degree. And like we said, when we're going to reduce, we keep the cos and this angle over here. We disregard the 180 plus. We only keep this particular angle. You see, these particular angles. These are the ones we are reducing to. But cos does not belong here. It's only 10. So we're giving it negative because cos only belongs in this quadrant, not this quadrant, not this quadrant. Right? And so we're giving it a negative because only 10 belongs here. But if it was 10, 190 degree, 10 in that form, and then we reduce it to 10 degrees, what would it be? It would be positive, right? Because this 190 degree that we started with does indeed belong to the 10 quadrant. And so that's how you would go ahead and do it. So with this all quadrant, what it would mean is, for example, you have sine 370 degree, which now 370 is, it goes beyond 360 degree, right? And so it's going to end up in this quadrant, in this all quadrant. So we would have to use this. So it would be sine 360 degree plus 10 degree. Reduce it, sine 10. So this sine, it's here, but as you can see, it says all. So it doesn't matter if you're going to use sine, cos, and 10. This all means that it includes, this quadrant belongs to all of these three trig ratios. It belongs to sine, cos, and 10, and thus all of them are going to receive a positive. If it was cos 370, it was going to be cos 10 degrees. If it was 10 370, it was going to be positive 10 degrees. In this case, with this example we did, since it's sine 370 degrees, it's positive sine 10 degrees, right? And yeah, that is just a basic introduction on how to look at the cost diagram. There's more that we're going to be looking at, but for now I just wanted to refresh your mind just to see it in a different perspective, right, before we indulge into much deeper things concerning the cost diagram. And so I will see you on the next video.